Hi, welcome to BC Video 9.1a Part 1, Introduction to Sequences and a Review of Factorials. So, the chapter is titled Infinite Series because the majority of the chapter is on series, and the difference between the word series and the word sequence is the word series means that you are actually adding together. It's the sum of the terms of a sequence. So a series would be something like 1 plus 2 plus 3, etc. This particular series diverges because if you keep adding these numbers, it just gets larger and larger and larger. Okay, but we're going to be looking at sequences. Okay, so a sequence is a set of numbers in a particular order, such as 1 comma 2. So sequences are going to have commas, whereas series are going to have plus signs between the terms. Okay, so you have the term. Sorry, I'm dealing with this laptop here. Okay, so for example, the sequence 1 comma 2 comma 3, there is such a thing as the limit of a sequence, which is the limit as n goes to infinity of an. So you can see if I keep going down this list, each one of the terms, and the terms are my an's. The first one is a1, second one is a subscript 2, a subscript 3. You can see if I keep going down, eventually I will keep getting larger and larger numbers. And we say, therefore, the sequence diverges because its limit is infinity. Same thing with 2, 4, 6, comma. Same thing with 3, 9, 27, comma. Okay, but then if you have something like 4, 2, 1, 1 half, etc., you can see that as I keep going here, the terms are getting smaller and smaller, and there's no reason to think they will not continue to be positive. So in this particular case, the limit as n goes to infinity of our sequence is 0. And we say, therefore, since that limit is equal to a particular number, we say that our sequence converges to the number 0. Now, if you look at a situation like the following, 1 comma, a half, comma, a third, etc., again, the numbers are approaching 0. So again, this sequence converges to 0. What's interesting about these two examples is later when we talk about series, when we take these terms and we add them together, what will happen when we add 4 plus 2 plus 1 plus a half, that series is actually going to converge to the number 8. So that sum is just going to get closer and closer and closer to 8. It'll never go beyond 8. And that's something we'll look at later. On the other hand, this sequence, which has the same limit as this sequence here, which is 0, later on when we look at the series, actually this series will diverge. So that's an interesting dichotomy right there. Just because the sequence of terms converges does not guarantee whether the series of those same terms will converge to a particular number. Okay, now, so they're going to define what a sequence is. A sequence is a function, is how they're going to look at it, whose domain is the set of positive integers. And that's because we're talking about the first term, the second term, etc. So what happens is, and the domain is n. So the function is going to be a function of n. And we're going to call that f of n equals to this expression an. And as we said, the n's are going to be 1, comma 2, comma 3. The first term, second term, third term is what that's going to refer to in the end. Okay, so the terms of a sequence, therefore, are a1, a2, a3, which is f of 1, f of 2, f of 3. Here's an example. They're going to define the sequence as the function of n equals 2n plus 1. That 2n plus 1 is your an. So if you look at this, a1, which is f of 1, will be 2 times 1 plus 1, etc., a2, a3, etc. So the way we're going to write this sequence is we're going to write it in braces. You're going to have braces an, and you're going to have equals 2n plus 1. So that's now you know that an is equal to 2n plus 1, so you can figure out a whatever. An is the nth term of the sequence, whereas when you put it in braces, it refers to the entire sequence. Okay? Later on, we will have a situation where the domain actually will begin at 0. So you'll have the 0th term, the first term, the second term. You'll see why when we get way further on in this chapter. Okay, so here's another. I don't know what happened right there. So here's the sequence Bn. 2n minus 1 over n, and the question is write out the first three terms of this sequence. So this is extremely simple. In other words, they want b1, b2, b3. So you simply go in and replace those n's by 1, and then by 2, and then by 3. So you can see that this sequence, if you were to write out the first three terms, it is 1 comma 3 halves comma 5 thirds, etc. Okay, factorials are going to come up a lot in Chapter 9. N is a positive integer in our case, and n factorial is equal to the product n times n minus 1 times n minus 2, etc. You've seen factorials when you dealt with permutations and combinations. So, for example, 4 factorial is 4 times 3 times 2 times 1, which is 24. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, which is 720. Now, there's ways that we can simplify factorial. So for example, n factorial over n minus 2 factorial, if you think about it, for example, if you think of n as being, say, 6, that would refer to 6 factorial over 4 factorial. If you wrote all that out, you'd realize that the 4 times 3 times 2 times 1 would cancel, and you'd just be left with 6 times 5. So if we look at the more general situation, n is, of course, larger than n minus 2. So we're going to rewrite the largest one as n times n minus 1 times n minus 2 factorial. Because, again, if you look at 6 factorial, it's 6 times 5, and in effect, times 4 factorial. And that's why the 4 factorials cancel. So what then happens is we can cancel out those two n minus 2 factorials, and that means that expression is actually equal to n squared minus n.